Hello students, today we'll do exercise 1.2 question number 2. Check the injectivity and surjectivity of the following functions. F is from n to n given by f of x is equal to x square. So we have to first check whether the function is 1 to 1. So the function is given as f of x is equal to x square. Take 1, the square of 1 is 1. Take 2, the square of 2 is 4. 3 goes to 9. So it is very clear that different elements in the set n will have different images. So it is 1 to 1. So let us prove it. How do you prove it? The algorithm to prove is take x1, x2, two different elements in the set n. That is the domain. If f of x1 is equal to f of x2, then we have to prove x1 is equal to x2. So f of x1 is x1 square is x2 square. So x1 square minus x2 square equal to 0. Therefore x1 minus x2, the identity x1 plus x2 is equal to 0. So x1 is x2 and x1 is minus x2. Okay, this is not possible because x1 x2 belongs to set of n natural numbers. So x1 is minus 2, x2 is not possible. So x1 is equal to x2. So we have proved that if f of x1 is equal to f of x2, x1 is equal to x2. Therefore the function is 1 to 1. Next we have to prove if it is onto. So 1 to 1 means it is injective. Now we have to prove if it is onto. Now, so the function is y, f of x is equal to x square means y is x square. So you get x is root of y. So for every y belongs to, if we take a y in n, can you find x, that is root y in n in the domain? Is it possible to find root y for all the elements in the codomain? For example, if I take 7 belongs to the codomain. Do we have root 7 in the domain? It's not possible because n is set of natural numbers. For every element belongs to n, the pre-image doesn't exist. For every element, the pre-image doesn't exist. For example, 7 or 11, all these numbers, the pre-images do not exist. That means the codomain is not equal to the range. For every y belongs to n, this is from the codomain. And root y doesn't belong to n in the domain. For y belongs to n in the codomain has no pre-image. That means some elements, not all the elements, isn't it? For example, if you take 9, its pre-image is there. If you take 16, so some elements are left out. Onto function means all the elements in the codomain should be used. All the elements here, some elements are left out. That means codomain is not equal to the range. Codomain is a full set. Codomain is a full set. Ranges only few elements, 16, 1, 4, 9, 16. Only the square numbers are the range. So they are not equal. So it is not onto. That means it is not surjective. Second question. F is from z to z given by f of x is equal to x square. So the function is from z to z. The first sum, it was from n to n. So there is a difference. The negative numbers are also included here. Okay. So minus infinity to plus infinity, the integers. And this side also it is from minus infinity to and the function is the same function here. F of x is x square. So we have to prove now. So if you take, it is very clear, because if you take minus 2 will go to, when you square minus 2, it will go to 4. If I take plus 2 and square, that also will go to 4. That itself, so you can see very clearly, it is not one-to-one. Different elements have same image. So one-to-one means different elements should have different images. Different elements should have different images. Here, different elements have the same image. So it is not one-to-one. But you have to prove, let us prove it is not one-to-one. Let us take two different elements, x1, x2 belongs to z. That is a domain. We are taking from the domain. So f of x1, if f of x1 is equal to f of x2 square, that means x1 square is equal to x2 square. That means x1 square minus x2 square equal to 0. That is x1 plus x2 into x1 minus x2 is equal to 0. So x1 is minus x2 and x1 is x2. So it is different. x1 is equal to x2 you should get. If you have taken x1, x2, f of x1 is f of x2. We have to prove x1 is equal to, but x1 is not equal to x2. No? x1 is equal to minus x2 also. x1 is minus x2 and x1 is x2. So we are not getting x1 is equal to x2. If f of x1 is f of x2, you should get x1 is equal to x2. You are getting x1 is minus x2 and also plus x2 both. So that is not correct. So therefore it is not one-to-one. It is not injective. Now we have to check whether it is onto or not. So the function is y is x square. So that means x is root of y. For every y belongs to z, any y you take. Example, you take minus 2. Now root of y, x should be root of y. X is root of y you are getting. So this is x, you are taking this as x, this as y. So if you take any y belongs to z, do you have root y here? For example, if I take y is minus 2, do you have root y here? No. Root of a negative number doesn't exist. It is actually a set of integers. So negative numbers we cannot find. Not only that, the other odd numbers, suppose if you take 3, root of 3, it is a irrational number. It is not there, the set of integers. Onto function means all the elements in the codomain should be used, but here some elements are left out. That means codomain is not equal to range. Range starts from 1, 4, that. So the other elements are left out. So codomain is not equal to range, because for any y belongs to z, every y, every element should have a pre-image. There is no pre-image. As no pre-image in the domain. For every y belongs to z, as no pre-image in the domain. Therefore, it is not onto. It is not onto. Therefore, it is not surjective.